we're ready to start the kick-ass schema evolution panel, which I've just thusly renamed. And I'm going to hand over to Michael Trier to moderate this. So go, Michael.
Thank you. I just want to start off again by saying thank you to Robert Lofthouse and the panelists for allowing me to participate today. It's definitely a privilege and an honor, and I know that this is a topic that a lot of people care about, and so hopefully we'll have a spirited discussion on the matter. But before we get started, I would like to offer our panelists the opportunity to present their different approaches to schema evolution, since this is a complex topic and something that a lot of people may not have had the opportunity to look into. We're going to take a little bit of time for this part of it. So first up is Simon Willison, and he's going to be presenting on his project, demigrations.
Okay, is this on? No? There you go. Okay. Let's have some slides. Right, so demigrations is a system which I released just last week, just in time for this panel. And it's something that we've been building at GCAP, now called Global Radio in London, to solve the problem that everyone has with Django development. And the moment especially once you've got a large number of developers working on the same code base. So I know a lot of people who've done sort of small Django projects kind of deal with the pain of changing their models and having to upgrade their database, because you make a change and you work out what the SQL command is to alter your table and you run it and that's okay. But once you're working with a large team, we actually have 14 developers now, you kind of need to share those around everyone so that everyone's development environment gets upgraded as well. And while you can just sort of stick that in the email to team at and put the SQL that everyone should run, it's kind of makes a lot more sense to have your migrations, your changes to the database kept in source control and have a tool that can apply those for you. So I've got a demo. This is inspired by Cal Henderson. This is another stupid blog engine. And let's say we've got a classic Django application. I've got an entry model. It's got a title, a body, and published. Now, if I'm using demigrations, there are a couple of things I do differently. First, I don't use syncdb anymore. Instead, I use the demigration command. And so you need a couple of extra settings. You need to put demigrations in your installed apps, and you need to set your demigrations directory, which in this case is just migrations here. And this directory is empty at the moment because I haven't created any migrations at all. If we show tables in MySQL, you can see we haven't got any database tables either. So I'm going to create a migration that adds that blog table to my database. So I do that by saying manage.py demigration, because I'm creating a migration, app, and then blog, which is the name of the application. And you can see it says created migration, blah-de-blah-de-blah, 001_blogs_models.py. Let's put that in my migrations database. It's also done something a bit sneaky. If we do show tables again, actually it hasn't done anything sneaky, but if I now say demigrate list, that'll show me a list of migrations that are available. So you can see I've got 001 blog models, and it hasn't been applied. If I do show tables now, that command actually sneakily creates a couple of tables. This is a one-time only operation, and these are the tables used by the migration system internally for bookkeeping. So I've got my migration. If I type manage.py demigrate up, it applies that migration, and that creates the table. So now I have a blog entry table there. I can say describe blog underscore entry, and we can see that that's got all of the fields that I defined in my model. Now let's say I go ahead and add a new field to that. I'm adding an allow comments Boolean field. I add that to the model, and I need to create a new migration which will add that column. So I can do that with the manage.py, hang on, that was a comma, not a full stop, manage.py demigration add column, and then I need to actually tell it which column I'm adding. In this case, it's the blog model, it's the entry table, and the column is called allow underscore comments. So I run that, and again, it creates another migration. This is 002. So if I do demigrate list, I can see that that's waiting to be applied. Demigrate up, again, applies that change. And if I run describe again, you can see that the allow comments column has now been added to that table. If you can go up, you can also go down. So if I say demigrate down, it'll reverse that, it'll remove that column, and if I look in the table again, it's gone. Now, down is something which is, it turns out it's really handy to have that in a migration system for a number of reasons. First, you've got stuff in production, you migrate up to the most recent version of your app, you realize that you've screwed everything up horribly and you want to roll back to that previous version. This means that you can do that. But actually, much more importantly, it's a development tool. It means that in development, you can add columns and add tables and all sorts of things like that. And then you can, if you decide that that wasn't something you want to check into Subversion even, you can then revert that. You can go back down again and get back to the stage you were in beforehand. I'll show you one more example. I'll add a new class. This is class comment, another model. So now I can say manage.py, demigration, add table. The application's blog, the model is comment. And that'll, again, create another migration, which I can then run. I'll run both of those. And if I do show tables, I've now got a blog comment table as well. Now, what the migration classes that are actually being created are these scripts that live in the migrations directory. So here's the first one. This is the one that was creating those initial tables for that application. And you can see it's actually just a really thin wrapper around a bunch of SQL. There's SQL up, which is the SQL that gets run when you run up on the migration, and there's SQL down, which is the SQL that gets run when you hit down. This is code generation, and the reason it's doing code generation is that you can't depend on things like Django's ORM when you're inside a migration, because what happens then if I've changed all of my models, and then I need to run that very first migration that I wrote weeks ago when my models look completely different. If there's a dependency on the ORM, everything breaks horribly. So you need to freeze things in time. And for the purpose of this, I found the easiest way to do it was just to keep that SQL around and drop that into a file. Add column does something slightly different. With add column, the migration class is actually an add column migration, which gets given enough information to construct both the up and the down SQL. So it gets told you're adding allow comments to entry in blog, and it actually puts in the full sort of SQL description of that column as well. And again, that's just enough information to automatically create the up method and the down method as well. I'll generate one more migration. Manage.py demigration add index. Let's say we want an index on that blog comment published table. And that migration looks like this. It's an add index migration. And again, it's just enough information to create that migration and automatically create a down method afterwards. So this is all really straightforward. But this is actually the second version of the migration system that we built. The first version was called S-migration for simple migrations. And it had a bunch of extra constraints on things like it expected that your migrations were all numbers in a row. So if you went 1, 2, and then 4, and were missing 3, it would assume that was an error. It turns out that that actually isn't such a good idea, because when you're doing branch development, and you've got 2 teams of developers in 2 different branches, it's useful to be able to leave gaps in the migration sequence, so that one branch has the tables they're working on, another branch has the tables they're working on, and when you merge those branches together, the numbers sort of fit in between each other. The other really useful feature of this migration system, which again came from lessons learned, is that if you do help demigrate, this probably isn't going to look so good on the small screen, one of the commands you have is mark as applied and mark as unapplied. So what that lets you do is essentially, it's kind of like the tools that Git give you to make completely arbitrary changes to your repository. It's sort of a power tool. And the reason you want that is if you've been messing around with your database not using demigrations for whatever reason, it's very useful to be able to sort of patch it back up to a consistent state by saying, yeah, well, pretend that I've applied that migration that added that table, because I actually added that separately with a different command. And there are other conveniences, like you can say migrate up to version 5, migrate back down to version 3. But overall, it's kind of the simplest thing that could possibly work. It's a couple of steps above emailing SQL to all of your teammates, and it lets you build up a history of things, but it really doesn't try to do anything too clever. So I think this is a good point to pass over to a migration system that does things a bit more cleverly, and so I'm going to hand over to Andrew Godwin, who will introduce South.
Andrew Godwin is a Django and Python programmer. He works half the year and the other half slouching as an Oxford student. He's created and broken many Django projects over the past couple of years, including boring CMS sites, carbon calculators, and history visualizers. So thank you, Andrew.
So South is kind of the next stage of what demigrations is. So when we were developing South, we had the same problem Simon had, especially with his development. And so the way we do things differently is that, oh, it's not changing slide. Oh dear, there we are. So one, migrations are essential for the reasons Simon described. You can't have sort of a fixed schema. It just doesn't work. So similarly,
Hit space, it's on slideshow play mode.
Thank you.
There you go. I've paused it.
Excellent. So there's that. Then there's also the branch development problem, which Simon described as well, which is where you've got to have migrations that combine together nicely. I mean, so for example, Rails' active record migrations don't do this. If you have sort of a missing number and go back later, it will just complain horribly, or just not know you've applied a migration. So that was essential for us. The other two things we found useful are database abstraction. So the project South was developed for is being developed on Postgres, but deployed on Oracle. So for us, it's very important that everything here is abstracted away. So whereas Simon has sort of pure SQL in his code, as you'll see in a minute, we have sort of more high-level stuff using Django fields. And the final thing there is interrupt dependencies. This comes up more in sites that have lots of simple apps. So a good example is when you have a forum and sort of user profile apps like accounts. So of course, a forum post model is going to depend on sort of the user profile because it's going to link to it in a foreign key. And so it's essential that you link back across and so that one's been created for the foreign key gets done. Otherwise, you'll find out eventually that your foreign keys are all going to hell. So here we are. So the traditional method with syncdb is this in Django currently. Is that you run syncdb and click your initial models, everything's fine and dandy, and then you need to make a change, for example, add some new fields. So what you have to do is essentially drop and recreate the database. There's also reset, but it does that exactly that kind of thing. So this is obviously bad. What South does, very like demigrations, is that when you start off, you tell South, I want to create a migration that has everything in it. So you say create migration -- initial. It sits there, scans your models.py file, writes one with everything already in it. And so that's like one half of syncdb. You then run this migration using manage.py migrate, which is our command. That does it. And then in those two steps, you've completely replicated the functionality of syncdb with only one extra command. So it's very painless. And then when you get to adding new fields, writing a new migration is very simple. Migrating is very quick, and you lose no data. So the idea is to make sort of entries as painless as possible to migrations so that you're not stuck writing a long initial migration with your models in it. You just run the command, rescan the models.py file, and it's done. So database independence here is the important thing. So this is how our migrations look. So you can see it's a step forward from demigrations in a way. So we have sort of abstracted away functions for creating database tables. So here we have the category table, and it's creating an ID, a title, and a slug. All you do is pass in the name of the column and the field that we actually take directly from models.py when we create these migrations. And we use the fields to determine the types and reuse the SQL that Django creates internally. So it's all sort of nicely forwards compatible with new types and your own custom fields, which is more important for us, because we have quite a few custom fields. Similarly, we have forwards and backwards migrations. Here you can only see the forwards call, but there's also some things like db.delete table, which you put in the backwards call, and that's all done for you automatically. So missing migrations is sort of a graphical illustration of the problem here. In this particular one, we have Bill and Amy, who are developing different branches of the same application. So first of all, they start off by sort of creating the first three migrations. Amy writes them together. She applies them. That's why they turn green. And then Amy goes away and creates a fourth one called Fizz. At the same time, Bill creates a fourth one called Foo. So they're both happy. On their own boxes, they apply the migrations. They all run successfully. But then they try and remerge the applications. And the problem here comes across, where you can see that the one that would logically come after Fizz has been applied, but Fizz hasn't. And so this is what us and demigrations try to deal with, is that the idea is that we can detect the holes in your application and we can fix them. So when South comes across this, it will stop you and say, you know, wait, there's a problem. You can do this to fix it. And you've got various options, including going on regardless, just applying them out of order, or rolling back to it and rolling forward again, which is the sort of the most stable way. Another important thing is dependencies, as I said. So here we have foreign accounts. So imagine that a post model depends on an accounts model. So here the line is, so the post has a foreign key to the accounts model. And so the idea is you have to apply the migrations correctly. If you just apply all the forum at once and then apply accounts, it's not going to work, because forum is going to get to post, try to create a table, and your database is going to complain saying the foreign key is pointing to nowhere. And so what South also has, we have a dependency resolver, where it goes through the apps and applies them in this order to make sure everything's OK. So that's the kind of theory behind South, is that it's like demigrations, but we have data independence and we have app interdependencies and things. And it's a very similar approach, in all honesty, but subtly different. But there is another different approach, and that is where Russ comes in. So let's hand over to Russ.
You need more introduction.
Don't be frightened by that. We got my slides up there? There we go. OK. So I'm here to talk about Django Evolution. Django Evolution is essentially my response to a mailing list thread that just would not end. Schema Evolution was a Google Summer of Code project in 2006. Didn't get completed at the time, and it didn't come to a place where I felt it was comfortable as a core developer that was going to ever get into core. So rather than go back and forth on the mailing list, I said, right, well, code speaks louder than words. Here's an example, and wrote it, along with a friend of mine who I used to work with named Benjamin Koo. OK. Now, for some reason, and I don't know exactly why, Django Evolution has got flagged with this magic moniker at least over this conference, and I've heard it said a couple of times previously. I would like very, very much to disavow anybody of that notion. There is nothing in Django Evolution whatsoever that is magic. It is all legal Python, it is all legal code, it doesn't do anything unusual, and it's all done by introspection of models. There is only one sense in which it is magic. Any sufficiently advanced technology is indistinguishable from magic. OK, so what am I actually trying to do with Django Evolution? Now, everything that Simon and Andrew have said is completely true, and I have absolutely no disagreement about why you need evolution, why you need schema migration, why it needs to happen, why it needs to be done as a collaborative process between developers. What specifically is Django Evolution trying to do? Well, at the core of the approach is an idea called hint and tweak, that the evolution system should be able to give you a good hint of what is wrong, give you a suggestion of how to fix it, but give you the ample opportunity to correct the hint that it has provided. Simple changes, the really trivial ones, either because you're a new user to Django and I just want this to be updated, I don't care, or the ones that are actually just really simple evolutions, should happen without any user intervention whatsoever. However, it needs to provide very easy access for customization purposes and access to raw SQL, because there are some things that, they are complex migrations, they are denormalizations and all sorts of things that an automated system will never get right. So you've got to provide that entry point. It needs to be self-documenting, by which I mean that if I sit down and I look at the migrations files, I need to be able to read to see what's going on and not have to sort of decode what the SQL is trying to tell me it's done, except when you've actually written raw SQL. And it needs to be self-auditing. That is, you need to be able to tell what have I actually applied, what haven't I applied, what state is my current operational database in. And where possible, it needs to validate. It's okay to go and have a migration file that says you need to run this piece of SQL. Is that actually going to fix the problem you have? Is it actually going to remove the column that needs to be removed or change the column that needs to be changed? So how does it happen? Well, okay, Django Evolution has essentially three important parts. At the very base level, there's a thing called the signature. The signature is a pickled summary of a database model. We read the Django DB models file, and we say, OK, what is the interesting parts of this? We don't care about the help text of a field, but we do care about whether or not DB index is turned on. We do care if you've got a DB column name that's override. We do care about the name of the actual field itself and its type. That signature is essentially then just turned into a great big dictionary, and it gives you a state of the Django model at the time at which you initially run syncdb. When you first run your syncdb, it generates a signature for your entire project. Every time you add a new model, you can generate the signature for that piece that you've just added. Once you've got that signature, you can diff one signature against another signature. So here is a signature that doesn't have a particular field. Here's one that does, and you can generate the diff. And the diff can then be used to generate a hint. The mutation is then an atomic unit of change. This is a way of resolving a single problem in a diff. The common operations are all built-in parts of Django Evolution. There is an add field, there is a change field, there is a delete field, there is a delete model. You can, however, also use it to define them. It is essentially just an abstract base class, or a mutation is just an abstract base class. And if you want to write your own fancy denormalize on a Tuesday mutation, you can. Go ahead. They can also be raw SQL. There is an SQL mutation where you just drop in a chunk of SQL you want to run. And mutations will generally speak, with the exception of SQL mutations, they know the effect they're going to have. And part of the contract for mutation, it says, this is what I do to a signature. This is how I change a model signature, and I need to be able to run that in a just test it out and see what it does mode. There is, of course, the exception of SQL mutations where you can't, without actually parsing the SQL, you can't know what's going on, but you can actually tell an SQL mutation, this is the effect I'm going to have on a signature if you do want to maintain that validation path. So here are 3 examples of mutations: one that deletes a field from an author, one that runs 2 lines of SQL, alter table insert, and one that's a custom, it does foo 3742 for whatever reasons it happens to do. The idea here is that you can read them and they should actually mean something. You know it's deleted a field, you know it's done my change, you know that it has done my mutation. Wrapped around the mutations is then an evolution. An evolution is an ordered collection of mutations. Okay, so one particular change that I'm making to the database is a collection of mutations that resolves a bunch of problems in one. There are 2 different flavors of evolution, hinted and stored, but regardless of whether they're hinted or stored, they are always stored in the database. The database maintains as an internal table what state is the rest of the database in, what Django models have been synced, what state were they in when they were synced. A hinted evolution is the best guess. Okay, it says, okay, I've looked at the diffs, this is the difference, I think we need to add a field, I think we need to change this field. If you want to, you can just say, execute that straight away, I don't care. But they can also be used as a prototype for a stored evolution. So the default mode for a hint is basically to say, well, this is what I think needs to change. It's just outputted a standard out. If you pipe that standard out to a file, you can just use that as the starting point for a stored evolution. It can't resolve ambiguous updates. If you've got an add field and you haven't provided a default and it's not and you don't allow nulls, so null equals false, you need initial data. Something needs to go in there. So it won't allow you to hint something that it can't resolve if it can't find out what the missing piece is. And it also can't fit in the missing blanks. So, obviously, if you need that initial data, you've got to again go and use a stored evolution to tell it what the initial data needs to be to fill that column. The stored evolution is the bit that we really intend, or Django evolution intends that you use. The hint is there to make it easy for newcomers, to make it easy when you're prototyping and you just want to bang something out quickly. The stored evolution is where the real money is. It's a named sequence of mutations. It's stored on disk. It's defined per application. So every application can say, I have a sequence of mutations that I want to apply, a sequence of evolutions I want to apply. This is the sequence. Do A, then do B, then do C. They're not numbered, but they are in a list. So you can say you need to do A, and then do B, and then do C. They're stored in an evolutions directory of your application, so they can be put into version control the same way you do the generated SQL files from demigrations and south. And the evolution sequence is also stored. So, you are storing the fact. It's not just, they are files on disk, they're not numbered, but you do know the order in which they need to be applied. So what does an evolution look like? Well, essentially just like that. This is an evolution that applies the 3 mutations that we were talking about previously. It imports some Python code, which is the built-ins and my little customized mutation class, and says, okay, in this mutation, I need to say, delete the field, run the my mutation, run the SQL mutation. Okay, that would be one file of many. The names of those files would be in the overall evolution sequence. How does it work? Okay, unlike South and demigrations, Django evolution maintains syncdb. There is no create table mutation. It's assumed that if your models when you run syncdb, any new model will be created. If you are then referencing that model, you've got a foreign key to the model you've just added, that will be a mutation that will run after you've done the syncdb. And when you run the syncdb, it says, okay, I'm going to compare the current state of your model files with the model files that I have on record that were there the last time you ran syncdb. They've changed, so you need to run an evolution. Okay, so how do you evolve? You use the evolve command. --hint finds out what has changed. --SQL tells me what's going to happen. It rolls out add field into the SQL that's actually going to happen. And --execute runs the thing that's actually going to be there. And they can be run in pretty much every combination. You can run evolve --SQL --execute if you want. You don't have to always hint. If you run with the hint, it'll run the hinted versions of the evolutions. If you leave the hint off, it'll start looking for stored evolutions in your directory. So what does it actually look like when you run it? Well, here's a hinted one that we actually run. Manage evolve --hint spits out the hint that it thinks it actually needs. Okay, I'm actually happy with that. I'm going to run it. The last thing it tells you is the trial evolution was successful, which means that it has gone through, it's tested that the evolution that it thinks it needs to run will resolve the signature differences that are there. And so then I actually need to run it, evolve -hint-x, also shorthand for --execute, and that actually runs it on the database. It does actually spit up a warning to say, by the way, this is going to kill some data, this is going to destroy things. Are you sure? Yes, no. So again, let's go back to the original goals. The core of the approach is hint and tweak. You need to be able to find out from the state of the models, what has changed, how can I fix it, and actually tweak on what is there, the sort of the default generated version for you. It's not magic, it's just doing a diff against two signatures. You can do simple changes, you can just apply the hinted diff if you want, but if you do want to have a heavily customized version or write your own mutations or whatever, you can. The mutations themselves are relatively clean and easy to read. They're also cross-platform with the exception of renaming primary keys in MySQL. It works across the board on Postgres, MySQL, and SQLite. It's also self-auditing because it goes through and checks that it's actually going to resolve all the changes that you've made are stored in the database, and it's validating where possible because it checks that the mutations you're applying actually fit the problems you have. If you've gone and defined a stored evolution that says, I'm going to add a field, then I'm going to delete a field, blah, 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 and that doesn't resolve the state of the database that was last synced with the version that with the version of the mutations you're running, it won't actually apply the evolutions. It always validates that it's actually going to solve the problem. So it's up on Google Code. If you want to play with it, feel free. That's all I've got to run through.
Great, thank you. All right, just to start off with, Simon, on your blog, a reader wrote, is it just me, but when I realized that Django didn't have this migration ability, I was surprised. Then I just started writing SQL statements myself when necessary. And in my opinion, this feature isn't big enough to deal with so many different projects working on it. So is this schema evolution thing much ado about nothing?
If you're the only person working on your project, then maybe it is. But this is all about, like, demigrations came out of the pressures from working with a team of people. I mean, it was literally 2 teams of 7 developers, so that's 14 people, 1 database. Something's going to go horribly, horribly wrong if you're not controlling the way that you share the modifications you're making. And I think it's also important, certainly the other 2 projects have thinking about applications that you distribute, things that are actually open source code that people install their apps, and then you need to push out a change, and you really don't want to say to your users, so if you haven't been paying attention for 2 weeks, you need to run these 5 SQL statements, whereas if you did the upgrade last week, you only have to run these 2 SQL statements. So I think it's undeniable that this is an issue the moment you move beyond one person hacking on one project.
Yeah, you only have to watch what happened when we released the new comments framework 2 weeks ago to see what happens. You've got to actually be able to tell people in a very easy way, just syncing is not going to do the job. You actually need to make some changes. And whatever framework you use, whatever framework Django ends up using, being able to automate that for the people who aren't necessarily SQL jockeys is a good thing.
Yeah, I mean, I agree entirely with these points. It may not seem like a problem when you've sort of started off with a simple Django app, like I often did, but even as a single developer, I find it's really handy to have these kind of migrations, because even sort of rolling back to use your previous data is a terribly useful feature, and once you've got it, you really miss it when it's not there.
Thank you. So, Russ, you talked about the state of your backend support, but both Simon and Andrew, you guys didn't really talk too much. So what is the state of your backend support? And let me just say that probably for some people, it's a non-starter if you can't support multiple backends, because a lot of people might develop on SQLite, but then are actually deploying to something like Postgre.
Oh, state of my support is it works across the board for SQLite, MySQL, and Postgres, with the exception of the primary key renaming in MySQL. There's a huge test suite that runs through all sorts of modifications on that, and yeah, SQLite one's not easy. The MySQL one's a pain.
I mean, so south is we have full Postgres and MySQL as far as the features that we have. So we have indexes, columns, tables. We don't have everything yet. We don't have SQLite or Oracle yet, which we're going to work on. But it's quite easy to add, and we've got sort of stub files already, so it's the sort of thing we would go towards.
So demigration's approach to multi-database support is kind of wishful thinking. We built it to work with MySQL because that's, in fact, we built it to work with MySQL using InnoDB only because that's what we were using. Before I open sourced it, I stuck in a switch so you can say, actually create my ISAM tables instead. and I created stub directories for SQLite and Postgres, and put a thing in the release notes saying, so hey, if you feel like contributing, getting it to work with other databases would be a nice idea.
And that always works.
Yeah. But generally, the approach at the moment, demigrations is really just managing files of SQL that can be applied and unapplied. And I think were it to go fully cross-database, the approach that South and Evolutions take, where you have an abstraction over those commands, is absolutely the right way to go. We just haven't needed it yet.
Okay. Migrating constraints are a particularly difficult problem to address because constraints typically only make sense in an implicit way. In other words, they're typically not explicit in nature. So how are you addressing the migration of constraints, or are you addressing the migration of constraints?
Yeah, that's a point of weakness as well. I mean, there are as far as the things that Django Evolution does, it does well across the board. The renaming of constraints is one of the things it doesn't do well. It does better, I think, on Postgres because the rename is actually carried along. Like, you don't have to rename the constraint to keep it with the field when it renames. So MySQL not so friendly like that.
So demigration has outstanding support for constraints in as much as you are completely welcome to write your own SQL that does whatever the hell you want to your database. And actually, this is what we do. I mean, anytime we need to add a constraint, we create a migration. We literally generate the code for the migration that creates the tables, and then add a couple of lines that add constraints afterwards. And we punted on all of the advanced features with the. You could create a class called add constraint, just like we've got classes for add index, but we haven't done it yet, and at the moment this is kind of the advantage of being deliberately stupid and just having SQL in a file.
Yeah, I mean, so in South, our approach is kind of similar to Evolution in the sense that we have support for, I think it's unique together is the only constraint we kind of support. And so there's a very limited amount of stuff that we can sniff the multiply file whenever you write them. It is, again, even in South, you're free to write SQL as you see fit. There's a db.execute SQL command, although we don't advise it for obvious reasons. But yeah, it's a sort of thing that just needs improvement in the various database backends, I think.
One of the particular difficult problems with data migration, and the Rails community deals with this one as well, is that if you use an ORM to migrate your data, then it's likely that future migrations will cause prior data migrations to break because the models are static. And I think, Simon, you referred to that in your presentation. I would think that both South and demigrations suffer from this, although I would think Schema Evolution doesn't because it's actually doing the migration based upon the model signature. Is that correct?
Yeah.
I mean,
yes, that's right. Essentially, internally there is a mock. It quacks like a duck. It looks like a model, but at any given point, it looks like what the model was when those changes were applied. We essentially are just passing that duck into the generate code function. In many cases, just the straight SQL backend that Django has. You'll notice the refactor that I did about 3 weeks before 1.0 landed was mostly to provide the interfaces that I could just pass my duck into where I wanted it. And the implementation on Schema Evolution, on Django Evolution, has an evolution operations module that is the other things, the add column, the add index, the renames and things like that. But because you're dealing with the duck, not with the actual model, you know you've got one that is correct at the interim points as well as at the endpoints.
So demigrations, people where I work are banned from ever using the ORM within a migration. And this is an issue, it's sort of a larger general issue, is how do you deal with actually modifying data that's already in there? Like if you're doing migrations that just change the schema, that's easy. The moment there's data that needs to be fixed around, you have to do extra work. With demigrations, we just say, you'll note that we have an up method and a down method. You can just construct SQL in there, but you can also grab a cursor, select data from the database, get it in a dictionary, manipulate it, put it back in again afterwards. This does mean that we've had migrations which have taken 6 hours to write that do some rather complicated fiddling around in the database to fix up data, and then a down method that does the same thing in reverse. So again, it's the advantage of the really stupid methods is all of these things are possible, but that doesn't mean that they're easy to do.
Yeah, I mean, so in South, the only place we ever touch the ORM is with foreign key fields, which require a model to go in and first parameter and with any data. So with foreign keys, we have, like evolution, we have mock objects, which have barely enough information to link to the other table, which is, as Simon says, quite devious. And yeah, we have the same problems with sort of data APIs. You can't rely on the model being there anymore because it's not, it's vanished. So perhaps something along the lines of mock models that really do work might be a good idea.
So Simon, with demigrations, I know that it has the ability to support extending the migrations through writing a custom class. And I'm just curious, Andrew and Russ, if your projects allow that similar capability of extension outside of the actual project itself.
Yeah. Oh, so South, a migration really is just a class with 2 methods in it, so you can write anything you like. The example where I showed of the field generating, our only command that auto-generates migrations at the moment creates the ones that just create a whole model table. And the rest of them you are currently left to fend for yourself, so you have to write db.addColumn so-and-so. So you are free to do anything you like inside them, as you could have extensions and subclasses, but it's generally a sort of free-for-all thing in South.
And yeah, I mean, I had the demo for my mutation. So yeah, you can. It's the idea of a mutation is it's just a base class. You need to be able to simulate what it's actually going to do and actually do it. But other than that, it's just a prototype, and as long as you implement the interface, you're fine.
One of the particular problems is versioning when you're dealing with different branches of code, which I think several of you guys referred to in your demos. Do all of your projects handle branching and merging of those branches well?
I can't say I've had extensive opportunity to test it myself. However, I've been led to believe it's been used in a couple of projects where they have. Essentially, because the database, any given instance of a database knows what signature it has been synced to. It knows there is a sequence of evolutions that's on disk. It tells you what order they need to be applied, as long as and it will also validate that the whatever SVN merge or whatever operation you've done will actually be consistent at the end of it. Fundamentally, yeah, it shouldn't actually be a problem as long as you're doing your SVN merges properly and you're validating the changes correct.
So in South we have a similar thing, as I said in the talk, where when you merge your change with another branch, South will pick up the fact that new migrations have suddenly appeared. And as long as they're sort of not terrifying, so for example, if you start overwriting other migrations in the branches, it's going to go wrong. But it can generally resolve sort of simple ones where somebody's added a model somewhere and the other group had a different model. It could just merge those together with one switch and just apply them out of order, and then it makes sure it's happy and says, OK, it's fine.
So we have a fantastically high-tech solution to this problem in demigrations, yet again. We have a wiki page, and you use the wiki page to reserve numbers for your migration. So different branches, if you're going to create a migration, you go to that wiki page, and you put in, you basically stick in a line with the number that you're going to use for your migration, and you do that before you create the migration, and the wiki means that other people don't create one with the same number. It's ridiculously low tech. It works extremely well. We've created 350 migrations using this mechanism across 2 branches, and we've never had any problems. Of course, the other thing that you have to watch out for is if someone makes a migration that alters a table in one branch and the other branch is making a migration that drops that whole table, then you're completely screwed. So we have a simple contract there, which is when you create well, firstly, the branches tend to be working on separate applications. If you have the slightest suspicion that your migration will affect the other branch, you go and talk to them first. And this system has worked pretty well for us with just sort of 2 branches of development.
Does the demigrations table come with a stick you can use to beat the other members of development that don't adhere to the policy?
Not quite, but we do have one stick. You can optionally disable the syncdb command, because when we introduced this, it took a while for the fact that we'd built this thing to percolate around all 14 developers. So in the end, we checked in some code that when you run syncdb, it said, syncdb is now disabled. Go and read this wiki page to find out how we do this now.
Yeah, I mean, so in South, with the whole syncdb thing, what we actually do is we override syncdb with our own custom version of it.
That's what we do, yeah.
Yeah, so except that R1 will syncdb all the apps that don't have a migrations directory, and then all the apps with a migrations directory will just sit there going, no, I'm not doing anything, it's your problem. So you can still use syncdb for things like Django contrib auth and things, which is very important for, but for everything else, it just dumps you and says, you should run migrate, otherwise nothing will work.
So this is something I find really interesting about South, is the concept of per application migration directories, which is something that we've avoided because
Django Evolution is actually per application as well.
Right, and so the reason we haven't gone that route is that our sysadmins want a very, very, very clear list of what is going to happen where. And so they really like having the single migrations directory, and they can go, okay, so there's 3 that haven't been run yet. Those are going to run in sequence. We can run those in our staging environment. We can actually eyeball the code to check what's happening.
Yeah, I mean, that's why you have the dependencies. The idea is that for any given combination of apps in Django, they'll always run in the same order because that's how they're resolved. And we also, the idea is to get migrations into separate apps, things like review board, for example. If you're changing the schema, you've got to sort of get them up.
So I see. So the contract then is you've got an application with 5 migrations in. Those will always be run one after the other, but it might be that some other application's migration is snuck in between 4 and 5.
If it depends on that, it will sneak them in. That's the guarantee.
Yeah, Django Evolution is exactly the same in that each individual application's sequence of migrations is independent. However, it does play an additional trick, and this is mostly because there isn't any internal dependency checking between individual applications. It does play the trick that if the same evolution name exists in 2 different applications, they will be applied at the same time. So if I've got a foo migration over here and a foo migration in the separate application, they will be synced as being happening at the same time, and the sequences will be aligned appropriately outside of that. The other one, in terms of the DB admins wanting to know exactly what's happening where, when, how, one of the modes that Django Evolution runs in is --SQL, and it will give you a dump of all the SQL it will run, and if you want to go through and audit that and go to town, if you just want to believe it, because it's always right, -execute, yeah.
So this is actually, we were going to put that feature in demigrations, what SQL are you going to run, but we couldn't because some of our migrations actually stop and select things from the database and decide what to do based on what's out there.
Yeah, that's at the moment all of the migrations that Django Evolution produce. The contract is you need to be able to simulate what you're doing, and you need to be able to tell me the SQL you're going to run. That is one. There is actually a patch which I can't. His first name is Graham. I can't remember his last name. There's got a patch in the ticket tracker which essentially says that the contract changes slightly to you tell me the operation you're going to run. That means that if it's a Python operation, if it's like, for example, loading a fixture, which is what he wanted to do, if it was any other operation, you can't reduce that to SQL, which is admittedly is a flaw, but or at least is a limitation, a different way of looking at things that you've got to then have to deal with.
Can South preview what's going to happen to the database?
So we can, to the extent, if you use the built-in database functions, we can tell what's going to happen. Because, so we have a --fake mode that just, like Simon's ones where you twiddle a database, does nothing, but actually pretends to. So you can run, so we haven't got one yet, but you can add a one mode where it just outputs a SQL is going to run but never connects to the database. But again, it's the same problem that if you start using cursors to connect and do random SQL queries that aren't through our small API, it's not going to show you those, especially if there's sort of conditionals in there, like ifs. And I think the problem is that for a certain complexity of migration, it's really hard to say what's going to happen because it depends on the environment. I mean, we've had this problem.
Yeah. I've been a fan of migrations, of schema migrations for a long time, and even still, I only use them in a development environment, and I'm wondering what your thoughts are about using schema migrations within a production environment.
We have very, very good sysadmins who originally came to us who have previously worked at like healthcare providers where if they screw something up, lots and lots of people die. So they're extremely competent. They're very conservative about what's going on, and some of the features in our system derive from those guys saying, no, we have to see the full list of what's going to apply. In particular, you may have noticed in my demo there was a table called demigrations_log, and that's literally just a timestamped every time anyone ran a command ever. It ends up in that table, which lets them do auditing of things. So yeah, the way things work are we do all of our development and then we package the things up that we want them to deploy, including the migrations that need to be run. They run it against a staging environment to make absolutely sure it's not going to screw things up. They take a full backup of the database before they apply them. And stuff never, ever breaks for us, which is, well, it's a testament to them rather than to our software. But I think I think migrations have a very important role to play in making control changes to your production databases.
Yeah, I mean, I agree. I think migrations are more reliable than fiddling around with SQL statements or resetting the database. I mean, from my experience, you can, as long as you can, because obviously migrations are predictable, which is the whole idea of them. So you can run them against your staging server. You can clone your server and run them against that. And I have yet to see a migration fail in production. So, whereas I've seen some horrible things when people have been fiddling with the database, and it's just, it's terrifying. It really is.
Yeah, I couldn't agree more. That I've lived through both. I would vastly prefer to have any schema evolution mechanism rather than trying to work out which files I have or haven't run, or which my data migrations I have or haven't run, and particularly when you've got multiple developers working on different branches, working in different databases who might be using the same database, and maybe I have and maybe I haven't. And it's just one more difficulty you don't have to live with.
Great. I have more questions, but I just want to let people know that if you want to ask a question, please go ahead and start getting up, and that way you'll have an opportunity to ask questions as well. Russell, I think one of the reasons people think that Django evolution is magic is because you generate signatures based on the model rather than introspecting the database. And do you feel like that's a more powerful long-term approach than managing the model changes separate from the database migrations?
Yeah, okay. That was original a design decision. If you go and read the FAQ that's associated with the evolution project, you can sort of see the background behind it. Essentially, I think that dealing with the model in a Django world makes a lot more sense. When you come from a Rails world, you basically you start with the database and then you build the wrapper around the outside. And essentially what you're saying is that the database is canonical and you write this Ruby code because that's what you need to do. And that, it works fine for Ruby, and I'm not slagging it in any way. That's the model they've taken. The database is canonical. Django really runs the other way. The Python code is what is canonical. The Python is what you're actually going to be using, and you generate the SQL from the original model. Now, yeah, that should be sure. If you go in and you start tooling around in the database and manually tweaking things, all bets are off. If you are manually creating your tables or using legacy tables or whatnot, all bets are kind of off. The argument I'd put is that the InspectDB has been in Django pretty much since, well, at least since was released. I don't know if it was completely day one. It's been there for a very long time anyway, and it's never worked 100% correct. It's a very, very hard thing to do. And if you can avoid the problem entirely, please do. The one weakness that, Django Evolution does have is that, when someone does tool around the database, the signature that has been recorded doesn't match what the database actually says it is. So at the moment, the recommendation is, well, don't do that. There is a possibility of actually getting in there and doing some introspection to check that the database signature is actually compatible with what, like using inspection to check that the signature that's stored is actually compatible, and you haven't been tooling around, but it's sort of I'm a one-man band working on this. Ben hasn't been working on it for a while. It's hard to do. It's definitely hard to do with the sort of correctness and that you need when you're dealing with this in a production environment. And I'm not comfortable putting myself in a situation where I have to say, yeah, this works 100% all the time, because it's really hard.
Go ahead, Brian.
So I think that's actually the principal philosophical difference here between the South and demigrations approach, because my assumption is very much that, I mean, when I was actually trying out Django Evolutions, the one thing that kept on happening is I kept on screwing up my signatures. I'm not entirely sure how I was doing it, but I think I have an expectation that the database is going to be manipulated outside of what Django's doing to it for performance things or views or whatever crazy type of stuff it is that you want to do. And so I think that's why demigrations actually works entirely independently of Django. If you're willing to throw away the little code generation tool, you can use demigrations and the up and down commands to manage a database that has nothing to do with the Django project at all, which is kind of handy, I think, as a...
The price you pay for that is that you never know that the migration you've applied is actually the right SQL code. It does rely upon having the DB admin that's actually going to check it, and this is right.
Yeah, and in fact, in demigration, you can run manage.py demigration app blog twice, and you'll get 2 migrations that attempt to add the same table. It doesn't do any validation of that kind of stuff at all. It's kind of up to you not to mess up on that front.
Yeah.
Go ahead.
When I was watching your demos, I was thinking about Cal's talk yesterday, and pretty much the big thing was Django won't work for Flickr in its current state. But it seems like that, I'm trying to work, I'm actually going to be ramping up a few projects, and it seems like, in the beginning, South and Django Django Evolution seem like things I would want to use in early production and stuff. But when I get to something that Simon kept saying was the fact that you would want to select stuff in the database and actually work with the SQL. So that would be something that I'd want to use when when the project hopefully gets bigger. The problem that I'm trying to solve in my head is like, what would Django want as a schema migration? Something for people that are running small projects, or something for projects that are larger?
Yeah, I think in preparation for this, we had a bit of a chat yesterday, and Simon and I were talking about it on Friday in the Django core meeting. What we really need is all three, or at least the best bits of all three. There is a place for just doing it with SQL, because that's the one you can actually trust. The sort of the cherry picking aspects of, I just want that migration. The up and down aspects of, I want to be able to push this forward. Yes, I want to put it back. And the Django Evolutions actually being able to validate it and run it against. Tell me what's changed. Give me a hint and spit something out. I would like to think that the end point of this argument is all three of us discontinuing the project we're working on, ending up in with a common base point, and it becomes Django Contrib Evolution, or whatever it needs to be called. And that when we get the best of all three worlds, rather than three different projects that have got each different parts of the solution right, but no one complete solution.
Yeah, I agree. I certainly think that the two aims are definitely not incompatible. I mean, there's so much we can do to integrate them both. I mean, Django Evolution's validation and sort of working out what's changed can easily be added to something that has static migration files, and you can just create them. So there's a lot of room here for sort of making something that 95% at least people can use, and possibly with raw SQL that nearly everybody be happy with, and then the other people can go away and write something that's more suited to their needs, that's complex or simpler.
So I think the reason we picked the order we presented is it's kind of ramping up the levels of cleverness, if you like. Demigration is a step above emailing SQL to each other. South kind of adds database independence to that and the dependency stuff. And then evolution is the thing that's actually looking at what your models are and trying to figure out what the evolutions are that need to be applied. And I think, I totally think that there could be a thing that does all three of those features and lets you use it at a low level or a high level, like from a high level point of view, depending on what you need to do. So I'm very hopeful that we can do something like that.
And also, if for no other reason than three guys working on three different projects is a lot less productive than three guys working on one project. So,
three smart guys. Go ahead.
For what it's worth, Rails changed how they did migration ordering, and now they use timestamps in the files, which seems to be a much better solution for the whole branching problem. Mm-hmm. Secondly, though, with South, do you do migrations per model or per app? It looked like in your example it was per model.
So they're per app. So that example was obviously just one model, but the general thing is, especially with the initial migration, which South create for you, which is like syncdb, it will just put all the models in that app in one big file. So you create them in a certain order so that the foreign keys resolve, and then you delete them in the right order. So it's very much app-based. You can do as many models as you like in one migration. It's certainly not per model. That would be sort of inefficient. I mean, the original version of South was, in fact, one model per file because that's what the generator did, but it's always been flexible, and we've changed it recently to have everything in one file because I think that's better.
Cool.
Most of you talked about the use of migration mostly to cater for production environments. I sometimes find it useful to refactor the migrations. How would you guys handle that?
So there's a feature in demigrations that kind of supports that. Because all the migration in demigrations is, and the same for South actually, it's an object that has an up method and a down method. And so one of the migrations that ships with demigrations is called compound. And a compound migration, you feed the constructor a list of other migrations, and when you say up, it goes up, up, up. And when you say down, it runs in reverse order and goes down, down, down. And that's basically all of the support I've got for refactoring things. And the idea is that if you create a whole bunch in development but just want to deploy one in production, you can combine them together like that.
I mean, yeah, so it's a very similar idea. With South, you can sort of subclass the things and call their methods. We have no specific compound sort of pattern there, but Yeah, we could say, as I say, we could easily add one very quickly. I mean, it's a very flexible thing because it's just 2 methods on a class. That's all it consists of. It's kind of letting you do most of the work. All the extra stuff we have, the generation, all that, is just sort of syntactic sugar on top of what essentially you run methods in a certain order with certain dependencies. Well, that's the sort of the crux of the thing.
Just so we can have some tension up here and actually possibly get a fisticuffs and some really interesting television, I'd actually play devil's advocate here and say refactoring is not something you want to be doing. If someone has applied a mutation, someone has applied a migration, you want everyone to be on the same page. You don't change things once they've been applied.
Unfortunately, I'm going to agree there. You only refactor them if you haven't checked into source control. The moment you've checked into source control, they're frozen forever. We've had people change migrations in the past thinking it won't cause any harm.
And
of course, it just screws everything up.
Yeah, I mean, exactly the same here. I really do not suggest changing your migrations when they run because you're going to cause yourself no end of trouble with things mysteriously breaking when you roll back past them.
So that question's actually reminded me of a topic I wanted to bring up, which is running migrations within a transaction. So this is something, we did this originally, and then we discovered that MySQL can't roll back anything that alters a table in a transaction. And the moment you understand that, you realize that actually you're kind of screwed. I mean, if something breaks within a migration running on MySQL, your database will end up in an inconsistent state. There is no way of avoiding that, which is kind of depressing, but that's why we have a big thing on our, in our documentation that says, back up your database first before you run this, because, yeah.
Yeah, same here. I mean, in South, all migrations are wrapped in transaction, with the idea being...
But you were Postgres first.
Yeah, but the idea being we're a Postgres shop, so you should be really using a database that supports transactions properly. But, that's just my personal opinion.
Okay, we got time for the last question.
I ran into the same thing as Simon with Django Evolution, where I probably did something I shouldn't have and mucked with my database, and now I'm kind of screwed. So one thing you may consider is just like a reset, punt. Like, can I just
ticket 60?
Over? It's in
I think if it's not ticket 60, it's something about
okay.
that. Yeah. No, there are two things. One, ticket 60, and two, there's a great big thing at the top of the fact that says this is not finished. It will break your code.
Yeah.
So I fully appreciate that there are things that I have done wrong. There's also the elephant in the room is when Django changes what a model means. So, for example, when query set refactor landed, what a one-to-one field meant changed in a very subtle way. There's been a couple of others that have bitten that as well. When that happens, there's a problem. Your old signatures and your new signatures are exactly the same. The database tables are not. So that's one problem that Django, that the intelligent approach has to solve. And at the moment, I don't have an implemented solution. I do have a notional solution, which is not particularly well implemented. If you look at the FAQ for how do I handle the query set refactor merge, it actually does tell you how to write a custom mutation that will work around that problem. It won't detect that you've just encountered a custom mutation problem because you've done an SVN up of Django. But yes, actually just saying, I know it's right, make it work, is yes a command I want to write, yes I got to get in there, yes I just got to find 30 minutes to do it. So
I want to thank you all for coming on today, and everybody give them a round of applause.
Thanks a lot.
Yeah.
Thank you.